Hello everyone, welcome to the channel Code Like Him. Let's see today's problem. Number of steps to reduce a number in a binary representation to 1. Given the binary representation of an integer s, return the number of steps to reduce it to 1 under the following rules. If the current number is even, you have to divide it by 2. If the current number is odd, you have to add 1 to it. It is guaranteed that you can always reach 1 for all the test cases. So in this question we are given a string s, which is the binary representation of a number, and we need to do these operation, and after whenever we encounter an odd number, we will be adding 1 to it. Whenever we encounter an even number, we will be dividing the number by 2 till we reach 1. So we need to return how many number of steps that took in total to reduce this number to 1. So let's see this example. This is the binary representation of 13. So 13 is odd, we will add 1, we will obtain 14. 14 is even, we will divide it by 2, we will obtain 7. 7 is odd, we will add 1, we will obtain 8. 8 is even, which is divided by 2, we obtain 4. 4 is even, which is divided by 2, we obtain 2. 2 is even, which is divided by 2, and we obtain 1. So total number of steps is 6. So the answer is 6. So the first approach will comes to the mind is, we will simulate the what is given in the what's given in the description, and we will counting each step and then finally returning the count. So it will be big of n square solution, because manipulating strings will be big of n time, and we will perform n times. The best case scenario will be 1 followed by various zeros, because at every 1 we will be discouraging the least significant bit. So for example, in this case we will have 1 2, we will have 2, we will divide it by 2, so we will be rejecting, we will be just consuming the 0, and we will have only 1. So best case scenario is 1 followed by various zeros, and in this case it will took n steps. So and if we have something like this, then this will follow, this will also take n steps, and binary string representation will take a big of n, so the time complexity will be big of n square. But there is a better way to do this. We will do it in the big of n time, and also without using any external space, by using this carry. So what is the concept here is, whenever we encountered any 1 in the least significant digit, what we can do is we can add a 1 to it, and then we will introduce a carry in our system, and this carry will be propagated forward in this string. So whenever a carry is set, it will always remain be set, because whenever we add 1 in a odd number, let's say we have this binary representation, and we will add carry, we will add this 1, so the carry will remain, carry will become 1, and this position will get 0. So whenever we encounter any least significant bit to 1, to just use this to consume this digit, to remove this digit from this string, from we need to do two operations. First operation is we will add 1, so 1 operation, and then whenever we add 1, so the string will become 1 1 1 0. So the 0 we need to after that the second operation will be divided by 2, so 0 will be removed. So in the 2 operation we will get rid of this digit. So this is what is written. So whenever we will be using binary sum, which will be s of I minus 0, which will giving the current string, which is whether it is 0 or 1, and then adding it by carry, and the modeling it by 2, because it can be only 0 and 1. If this binary sum is not equals to 0, it means it is 1. It means we need to do 2 operations, first adding 1 and then dividing it by 2, so we will consume this 1. So this is written here, and whenever a carry is set, it will always remain be set, because it will be propagated ahead. So in this case also 1 1 1 will be our output after discarding this digit, and again we will, that 1 1 1 will be 7, and adding, and 7 is an odd number, and we add 1. So this 1 all these 1 will be discarded, all these 1 will be converted to zeros, and 1 will be added ahead. So when you see the binary representation of 0, it will be 1 is followed by 3 zeros. So like that on, we will be forwarding this our carry, and compute the result. So to get more info about how this works, you need to try run this over this question, so it will become more clear. So guys, if you find this video helpful, please like this video and subscribe to the channel. Thank you.